Hello again. Finally, in these following couple of lectures, we're going to do some example in which we will see how we can easily determine the location of a centroid of a plate. So in this first lecture, let's assume a plate that looks like so. So you see it has a trapezoidal shape, but there's a rectangular opening here close to the right end. And also at the bottom, there's a semicircular cutout from the plate. So two areas that are missing from the entire trapezoidal shape of the plate. Let's add some dimensions, and in this case all the dimensions are in millimeters. As you can see, and also for the semicircular cutout, the radius of this is 30 millimeters. You have to obviously locate the centroid of this plate. So how do we deal with this? Well, the first thing that we have to do, if not already given in the question, is that we need to select a reference system. We need to choose a system of coordinate axes from which we will measure all the coordinates. So we can select one like so, x and y, at the bottom and at the left edge of the plate. And then we can proceed to the second step, in which we will divide the plate into a number of elementary areas. And in this case here, we can look at the entire trapezoid, and we can divide this trapezoid into a rectangular area and a triangular area at the right side of the trapezoid. And then subtract from everything two holes, the rectangular hole and the semicircular cutout. So here there are the rectangular area, number 1, A1, the triangular area, A2, number 2, the semicircular cutout, number 3, having an area of A3, and finally the fourth area, it's the rectangular area here, having an area of A4. These two, don't remember, they're holes. They're missing material. There's no plate there. So we need to remember that. Then, in the third step, we will have to calculate the areas of these four elementary elements, locate their centroids with regard to the selected coordinate axes, and then we have to perform the calculations in order to determine the coordinates of the centroid of the entire composite plate. So these are the centroids C1, C2, C3, and C4, roughly located approximately on the diagram. It's good if we can draw these diagrams as close as possible to scale, so we can represent these locations as accurately as possible. And then we can perform the calculations in a table. Or if you prefer, you can just plug in the numbers into the formulae for x bar and y bar, but it's much simpler, more visually meaningful if you use a table, and easier to follow. So if we use a table, the first column will be the number of the area under consideration, the second column with the actual area of each element, Then the coordinates of the centroids for each element, xi bar and yi bar. And then the products of xi bar ai and yi bar ai. We have 4 areas. Area 1 is 12,000 millimeters square. The second area 3,000 millimeters square. The third area is 1,414 millimeters square, but negative because it's a hole, and the same a negative area of minus 800 millimeters square for area number 4, which is also a hole. The centroids, local centroids now for each area, 60 and 50 millimeters for area number 1, 140 and 100 divided by 3 for area number 2, 60 and that's a little weird number, 12.73 millimeters for area number 3, and 120 and 40 millimeters for area number 4. Now, the y coordinate of the centroid for area number 3 is actually 4r over 3 pi for a half circle, and you can find this value from tables. There are tables in the textbook or elsewhere, and you do not need to memorize this because it will be given in an exam to you if necessary. All you need to memorize is the centroid for rectangles and triangles, right? At the intersection of diagonals for rectangles, and 1/3 from the base and 2/3 from the tip for triangles. Now, having done the multiplications in the last 2 columns, taking account of the algebraic sign, all we have to do is sum the columns of area and the last 2 columns as shown. And then finally, once we've done that, we go to step number 5, and in which we actually calculate the coordinates of the centroid by using the formulae that we've learned recently. So x bar equals to sum of xi bar ai divided by the total area of the plate. So 959,000 divided by 12,790. So the x coordinate of the centroid is located 75 millimeters from the y, measured from the y-axis, and y bar equals to the sum of yi bar ai divided by, again, the total area of the plate, and that will give us 50.8 millimeters positive measured from the x-axis. Now, in the end, all we have to do is represent the location of the centroid on the diagram. It will be roughly here, CG, the centroid of the composite plate, 75 millimeters to the right from the y-axis, and 50.8 millimeters roughly in the middle, just above the middle, measured upwards from the x-axis. So that was an example in which we dealt with holes in a composite plate, and we will do another example in the next lecture. Thank you very much for watching this one.